something. Hey, 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 hey.
Wait, I gave a number in here, right?
Yes. So, yesterday we graphed these two, right?
Mm-hmm.
And if you graph them, I believe they cross at x equals 0, y equals 2,
Mm-hmm.
I believe. Well, I don't know if you noticed or not, but that graphing is kind of laborious. It takes forever. You got to go through all those steps, and then you plot one point wrong and everything's all out of whack. So I would like to show you today a couple other methods that you can use. And no matter which one you're using, here's what I would suggest. These are my two equations. I would suggest for both of them, get x and y on one side and the number term on the other side. So for this one, I think I'm going to just minus 2x. So I have negative 1x. Is that what I have? Is that what I have? I feel like I'm not at my mental best. Is that what I have? I don't like all those negatives. You mind if I multiply everything by negative 1? X plus y equals 2. Good? And then this one, same thing. And I get x minus y equals negative 2. So those are my two equations. And if I don't graph, there's two other things I can do. One of them is the substitution method. One of them is the substitution method. Here's my first equation. Here's my second equation. X minus y equals negative 2. And I'm pretty sure you know what substitution is, right? So substitution works best when you have a variable that has a coefficient of 1, preferably a positive 1. Well, we've got lots of coefficients of 1, 1, 1, 1. We have a lot of coefficients of 1. It does not matter which variable you pick, x or y. The most important with substitution is that you want to have a coefficient of a positive 1. So you can take your pick. I have x and y and x. I'm just going to pick x because it's the first one. It doesn't really matter. You could pick y if you want. I pick x, and I want to get that x by itself. So x equals 2 take away y. Do you see that? All I did was get x by itself. And it doesn't matter if you picked y, then you're going to get y by itself. Really doesn't matter. But once you have that x by itself, you're going to take that value for x and you're going to substitute in place of x in the other equation. So what is x equal to? X is equal to 2 minus y, right? So in place of this x, I'm going to put what x is equivalent to. See it right there? There's my x take away y equals, negative 2. Are we good? And now you're just going to solve it. Now you should have an equation with only one variable. Isn't that nice? So solve it. I have 2 minus y. Is that minus 2 y's right there? Now what? Do I have all the letters together? I have all the letters right here. I have to get rid of what's with it. Minus 2 minus 2. Then what? Right, good, yes. Divide by negative 2. And what do you get? Oh, look at that. Y equals 2. Same as what we got when we graphed it, wherever I wrote it, over there. Same as what we got when we graphed it, but I think it went a little faster. Yes? And then you're not quite done because remember you need the x that goes with it. But you should have it all set up for what x is equal to. You're going to substitute again the value for y. X equals 2 take away y, but what is y? 2 take away 2? So x is 0, y is 2. Same answers we got when we did it by graphing. Isn't that slick? Isn't that slick? Then the other thing you could do with this, I'm going to write those same two equations again. The same exact two, x plus y equals 2, and x minus y equals negative 2. The addition method, or sometimes it's called, I think I'm getting shorter, the elimination method. It's called addition or elimination. What do you do when you eliminate? Get rid of. Get rid of. So with the elimination method, here's what you want. You want to look at the two equations and have variables that are opposites of one another. Watch this. Talk about quick. Do you see how these two are opposites? If you have opposites, all you have to do is add the two equations together. What's x and another x? What's y and negative y? Eliminate, right? They're gone. And over here, what's 2 and negative 2? Divide by 2, divide by 2, and I get x equals, oh, wasn't that quick? Nice. And then all you have to do is pick one of the two equations, because remember, we still need to find y. So from there, it doesn't matter which equation you pick, you should get the same answer. I just chose that one because it's the first one. Doesn't really matter. Plug in x equals 0. And what do you get? Y equals 2. Notice you get the same two answers you got when we used substitution, which was the same two answers we got when we used graphing. Isn't that nice? Isn't that nice? So now you have 3 ways you can solve any system of equations. You can graph them, you can use substitution, you can use the addition or elimination method. I don't think I'd pick the graphing method if I were you. It takes too long, right? It's like trying to ride your bicycle from here to Green Bay when your friend's got a car you can ride in. You'll get there, but it's going to take forever. So either substitution or the addition method. Now, the two equations that we had, either one works well. So if you have coefficient of 1 on any of the variables, then you can use substitution. Because remember, with substitution, you want to get either x equals or y equals so that you can substitute that in. The addition method, this one works well if you have opposites. If you have opposites. What was the other one I gave you? 24 and 27. I don't want to do that one. I want to do number 8. 2x minus 3y equals 7. Solve. 2x minus 3y equals 7. And 3x, oh, I don't want to do that one. Equals 3. How about this one? Oh, how about this one? No. I guess I'll use this one. I don't think that's right. Plus y equals 5. So if you had your pick for this one, you could use substitution, right? Down here, get y by itself. You could. But I want you to use the addition method. Are there any opposites? I have 2 and 3. I have negative 3 and 1. There are no opposites. But if you don't have opposites, you can make them opposites. How would you make them opposites, Caleb? You know what I would do? See this negative 3 right here? Remember, you're allowed to multiply or divide or add or subtract as long as you do it to both sides. Well, what would I multiply by then? To make these opposites? I would multiply this whole equation by 3. Leave the top one alone. So 2x minus 3y equals 7. But the bottom now, we're going to multiply by 3. Watch what happens. 9x plus 3y. And don't forget, you have to multiply both sides. So that's going to equal 15. Now do you have opposites in the middle there, the y's? Yes. So now we should be able to add up the two equations. What's 2x and 9x? 11x, right? Here, negative 3y, positive 3y drops out. We eliminated it. It's gone. And over here, 7 and 15 is 22. Well, would you look at that? Divide by 11, and you get x equals 2. We're not quite done yet because we need to figure out what y equals. I don't know, maybe this one? It doesn't matter which one really. Pick one of the equations. And you're going to substitute. If x is 2, you're going to take that value for x and plug it into the other equation, right? So I have 3 times x plus what? Plus y. Oh boy. Equals 5. I told you I'm not at my mental best today. Forgot to take my vitamins. I think I need to do 2. So 3x plus y equals 5. But what is x? We just figured out that x was 2. So now I have 6 plus y equals 5. Minus 6 minus 6. Y equals negative 1. And remember, what we found was x and y values that will work in both of these original equations. That x equals 2, y equals negative 1, would work in both of those. So do you see how if you don't have opposites, you can make opposites by multiplying? Isn't that kind of cool? Oh yeah, really cool. Really cool. Anybody with questions so far? I'm going to show you one more thing. I'm going to show you one more thing, Madison. But you'll be gone. Are you having birthday cake? No? Oh. I used to always pick chocolate, I used to always pick yellow with chocolate frosting.
They don't get us cakes anymore.
No. I love a good birthday cake. How about this one? 2x minus 3y equals 3. 2x minus 3y equals 3. Bye, Madison. I hope you have a good rest of your birthday.
Thank you.
See you Friday.
Adios.
2x minus 3y equals 3. 5x plus 2y equals 17. 5x, 2y, 17. I don't think anyone is on with us, so we won't care about them. But five x plus 2y equals 17. Now, are you looking at those? Definitely, for sure, this is not going to be a good one to use substitution. Do you agree, Brooklyn? Because I don't have any 1x or 1y. That's not going to be a good one to use substitution. And I don't feel like graphing it. So our only other possibility is the addition or the elimination method. And remember, with the addition method, we want opposites. See, those two are opposites. See, they didn't start out as opposites, but we made them opposites. So, is there a chance we have opposites? Do I have any opposites? No. So, our only other hope is to make opposites. How can I make opposites? I'll give you a hint. For this one, you're going to have to multiply both. Brooklyn, what would you do?
You can multiply the first one by 2.
She says multiply this one by 2 and
The second one by 3.
by 3. And if you do that, what are we going to get? 4x minus 6y equals 6. Don't forget to multiply. That's a common mistake. Everybody forgets to multiply that last number. The other equation, that's going to give me 15x and 6y. Oh my. Is that 51, I think? And now at least we have opposites, right? The point here is sometimes you're going to need to multiply both equations by something. The y's drop out. Here I'm going to have 19x equals, is that 57? Oh, would you look at that? What do we get? And then take one of those equations, it doesn't matter which. How about 5x plus 2y equals 17? X is, so 5 times x, but x is 3. What am I going to get? 15 plus 2y minus 15. Looks like I get 2y equals 2. So what's y? 1, I think. I just have to show you one more thing, just because it's so cool. You're going to think it's so cool. Watch this. Alex says He wants to take this equation and multiply it by 5 instead. And he wants to multiply this one by -2. Can he do that? What's that going to give him? 10x minus 15y equals 15, and -10x minus 4y equals, oh boy, is that -34? Add them up. Divide by -19, divide by -19, what do you get? What y was when we did it the other way. I'm not going to plug the x in, but you get the idea that there's more than one way to do most of these and still come up with the right answer. So today, we're going to do a few more of these, but instead of graphing, you have your pick. You can either choose the substitution method or the addition elimination method. I don't care which you use, but I would suggest you do a couple each way. Do some with substitution and do some with the addition method so that you get both ways. Does that make sense? Do you have questions? Do you have questions? Are there any questions? Does anyone have a question?